4,300 guests live in five-star luxury. They can shop in a 130-meter-long mall, ride a surf simulator, and enjoy a show in a 1,000-seat theater. It's 18 stories high, and it floats. At its launch in 2008, the 160,000-ton Independence of the Seas is the biggest passenger ship in the world and the pinnacle of marine engineering. Her very existence is the result of over 150 years of engineering evolution. 5 groundbreaking leaps made by 5 key ships. At the heart of each lies a breakthrough that fuels the unstoppable growth of the cruise liner. One by one, traveling up the scale, we'll reveal the incredible stories behind these vessels and the inventions that made each one bigger than the last. 5 ingenious leaps forward. From big to bigger into the world's biggest. San Juan, Puerto Rico. Passengers are boarding the Independence of the Seas for a week-long luxury cruise. For many, the 3,000-kilometer trip through the Caribbean is a once-in-a-lifetime experience. For Captain Tio Strajicic, who takes the helm today, this isn't a bad place to work either.
It's a passenger ship that you can describe as a huge city, moving a speed of 22 knots across the oceans, being driven from the place that looks like Starship Enterprise command bridge. So it's a very interesting place to work.
This voyage will take the Independence of the Seas to some of the most glamorous destinations in the world. But for many passengers, this huge floating luxury resort is a destination in itself. To understand how she can claim her place as the biggest cruise ship ever built, we must travel back in time. Our journey begins in Victorian Britain with an engineering genius and his landmark ship, the 1,300-ton Great Western. At the height of the Industrial Revolution, steam-powered machines were transforming the world. One visionary engineer was about to use a steam machine to shrink it. Isambard Kingdom Brunel was a colossus of the railways. Nothing could stand in his way as he blazed a trail of iron across the entire nation. His masterpiece, the Great Western Railway, stretched all the way from London to Bristol, a port that opened onto the Atlantic, where it seemed Brunel's Great Western Line could go no further. But in 1835, during a railway company board meeting, Brunel had a brainwave. as historian Anthony Burton explains.
Why stop there? Why not build a steamer and go across the Atlantic to New York? Everybody thought he was mad, but one of the directors didn't. He came up to him afterwards and said, let's do it. Let's form the Great Western Steamship Company.
At the time, the only ships that crossed the Atlantic were powered by wind. The journey could take up to 2 months, depending on the weather. So Brunel decided to build a ship powered by steam to make the crossing much quicker. His Great Western steamship needed 650 tons of coal for the Atlantic crossing. To hold this much coal, Brunel had to make his ship 72 meters long.
The Great Western was going to be the biggest wooden ship ever built. And there's a problem with wooden ships out at sea. If they sit on top of a wave, then the ends tend to droop. If they sit between waves, the middle starts to droop.
If Brunel built such a huge ship from wood alone, its hull wouldn't be stiff enough to cope with big waves. It would bend, twist, and eventually break.
So it needs to be made rigid. So Brunel turned to a material he knew very well from his work on the railways. He turned to iron.
Brunel bolted a lattice of iron girders to the inside of his wooden ship. This formed a rigid skeleton that stiffened the hull. Brunel's Great Western was now fully braced for her first encounter with the Atlantic Ocean. Not only did she withstand the crossing, but on the 23rd of April 1838, she arrived in New York after just 15 days, half the time of a sailing ship. The Great Western completed Brunel's grand vision of a single steam-driven transport line stretching from London to America.
The success of the Great Western was an important event in the history of seafaring. It proved all the doubters wrong, and it showed one thing above all: big was best.
The independence of the seas takes the idea that big is best to the extreme. This giant is 120 times bigger than Brunel's Great Western. She's longer than 3 football pitches placed end to end, and weighs as much as 430 jumbo jets. Building such a big ship is far from straightforward. Construction work on the Independence of the Seas, the biggest cruise ship in the world, began in Finland in 2006. Her hull was made from 32,000 tons of steel. But simply using a lot of metal didn't necessarily guarantee a strong structure. The key to her strength was the way the material was arranged. Engineer Ed McCann explains.
It's one of the principles of structural engineering that material works better if you put it in the right place. And to demonstrate this simple fact, I have here a piece of folded up cardboard spanning between these two here, and let's see how good it is at carrying blocks. And if I pop this on there, we'll see what happens now. And through she goes. So I've taken the sheet of cardboard that we were just looking at, and I've made it into a different shape, a shallow box. There it is. I'm going to get myself my concrete blocks. We had 2 on last time. There's 1. First of all, you can see it doesn't deflect anything like as much as it did last time. There's another one. So it's taking 2. Now last time 2 fell straight through to the floor. See if it'll take 3. We've got 3 on there. And what you're seeing here is that we can double the load carrying capacity of this sheet of cardboard simply by organising the material and putting it in the right place.
To make their ships strong, designers working on the independence of the seas also formed their steel into rigid boxes, over 170 of them. Each box was up to 32 meters wide and 22 meters long. Engineers built the boxes in huge hangars where they painted them and installed wiring and plumbing. They then transported them to a dry dock for final assembly. Workers used cranes to stack the massive boxes together like a giant 3D jigsaw puzzle. They used hydraulic jacks to align them precisely. Workers then welded them together to create a rigid honeycomb of boxes. This makes the structure strong enough to withstand the pounding of the biggest waves in the heaviest seas. Back in 1838, Brunel's Great Western crossed the Atlantic in just 15 days. But Brunel was already dreaming of an even bigger transatlantic steamer, the 3,300-ton SS Great Britain. He wanted this ship to leave the Great Western's paddle wheels churning helplessly in its wake. The SS Great Britain is preserved for posterity in the dry dock in Bristol where she was built in 1839. Her vast bulk is still impressive today. But her most revolutionary feature is hidden beneath the waterline. Brunel's original plan was to propel the SS Great Britain using paddle wheels, just like the Great Western. But he knew from experience that paddle wheels had problems. Out at sea, a passing wave can force a ship to roll to one side. This leaves one wheel spinning uselessly out of the water. With the next wave, the other wheel is lifted clear. With the paddles dipping in and out of the water, lots of engine power is wasted. To solve this problem, Brunel turned to a clever mechanism invented by one of the greatest minds of ancient Greece.
It was Archimedes in the 3rd century BC who came up with this device. It's a helical screw. It's like a spiral, goes all the way up the central column. And if you rotate that, it will move water. It was a basic pump. So it fitted inside a column, like that. And now the Archimedes screw is all set to go. What we're going to do is switch on the motor. It's turning. Now we need some liquid. So we're going to fill up the bowl and let's see what happens. You can see now the liquid is being pulled up the column, right up to the top, and it's overflowing. What Archimedes had made is an efficient pump. Now, turn the whole thing on its side, fasten it to a boat. Now the water's being forced this way, which means the ship is going to be pushed that way. You've just made yourself a propeller. Unlike the paddles of a paddle steamer, the propeller was always under the water, providing maximum power all the time.
But Brunel's new propeller was unproven. Naval architect Tristan Smith knows that to prove a theory, you can't beat a demonstration.
Brunel wanted to make some impression on the public that his idea of a propeller, propelling a ship through the water, would be more efficient than using a paddle wheel. So he set up an experiment where he had two ships. One was equipped with a paddle wheel and the other was equipped with a propeller. Heavy rope strung between the two boats was used to act as a tug rope so that they could perform this tug-of-war competition.
Tristan ropes in his colleague Paul to help him rerun Brunel's experiment in a test tank.
In the actual experiment, the paddle steamer had a slight head start, so we're going to replicate that here. So when you're ready, 3, 2, 1, go.
The paddle wheel boat on the right pulls away first.
I think you're going to lose this one.
You're winning, you're winning. Hang on a minute, I'm coming back.
But despite the paddle boat's head start, the propeller proves much more efficient.
But now you're starting to pull me away. Oh dear.
Great.
So conclusively a win to the propeller boat.
Thank you.
Brunel's demonstration proved that propellers were the way forward. When she was launched, the SS Great Britain was the biggest ship ever built. And thanks to her powerful propeller, in August 1845 she crossed the Atlantic in the record-breaking time of 14 days, a whole day faster than the Great Western. Dawn in the Caribbean. It's day 3 of the cruise. Each night while passengers sleep, the Independence of the Seas sails to a new port. She then docks for the day, allowing passengers to explore the local area.
Port 5.
This morning, Captain Strajicic is preparing to dock at the small harbour on the island of St. Thomas.
11 knots coming down.
There's no margin for error. The narrow channel into the harbour is very shallow and notoriously difficult to navigate.
I have 7 knots right there, I keep it in.
345.
So how does Captain Strajicic steer this massive ship? Accurately maneuvering such a huge vessel with a traditional propeller would be impossible. The propeller's drive shaft only allows it to point in one direction. So instead, designers positioned the Independence's propellers on rotating mountings called azipods. They can spin 360 degrees, moving the ship in any direction. At the front of the ship, 4 additional propellers pull water from one side of her hull to the other, moving the bow sideways. The azipods and bow propellers work in unison to give the ship unparalleled maneuverability. She can even turn on the spot. This is power steering for ocean liners.
Good.
The innovative propulsion system allows Captain Strajicic to steer the ship into St. Thomas's small harbour in just 30 minutes.
With control that we have in any kind of weather, we can actually make better and easier fit than some smaller ships.
Giving Captain Strajicic this much control takes some of the biggest propellers in the business. Each weighs over 27 tons.
They are Russian submarine propellers. Quite expensive because they're made out of nickel, aluminum, and bronze, which is very precious metal in the industry. So they cost a few dollars.
The propellers must be kept in top condition. So when in harbour, Chief Engineer Ole Pedersen regularly sends the ship's team of divers down to carry out an inspection.
Divers in the water.
Even in the clear waters of the Caribbean, the propellers can pick up seaweed and barnacles.
They get hairy and fuzzy with green stuff. You lose efficiency of the propellers, and then your fuel consumption goes up.
The diver carries a video camera so that Ole can direct the inspection.
Hold it right there.
We're here on the port side azipod. We're going to start down here with blade number 1. Which is right over here. Blade number 1. As you can see here, lifting eyes in good condition, nice and flush.
The diver's reports are good. The Independence's propellers have a long way to go before they'll need an overhaul. And later that evening, Captain Strajicic uses them to safely leave harbor. Back in 1843, the propeller-driven SS Great Britain crossed the Atlantic faster than any other ship. But at speed, passengers found it hard to stomach the rough Atlantic seas. Designers building the Conte di Savoia would need to find a way to give her smooth passage. The late 1920s. Passenger planes had yet to conquer the Atlantic, so traveling by ship was the main way to get from Europe to America. This was the golden age of the ocean liner, and competition for passengers was fierce. In 1929, Italian designers wanted to build the greatest liner of them all. She would comfortably carry over 2,000 passengers. She'd also serve some of the best food at sea. But on the notoriously rough Atlantic crossing, that posed a problem.
The trouble is, you can't really enjoy fine dining if you're spending most of your time with your head in a bucket being sick. What was wanted was a ship that would guarantee no seasickness. And how are you going to achieve that? We have to stop the wretched thing from rolling about.
To stabilize their new ship, Italian designers used a device with some very unusual properties. A heavy spinning wheel called a gyroscope. Using a surfboard and a spinning bicycle wheel, Tristan Smith shows how a gyroscope can affect a ship's roll.
So, spinning up the gyroscope.
As Tristan tilts the gyroscope forwards and backwards, the spinning motion of the wheel has a surprising effect. It forces the surfboard to roll from side to side.
So as I tilt it away from me, I roll to the left. When I tilt it towards me, I roll to the right. Towards me, to the right, away from me, to the left. So as I can use the gyroscope to control the motion of the board, if we scaled this up, it could be used to control the motion of a bigger ship in waves. So if there's enough force to capsize the board, there's surely enough force to stabilize a bigger ship.
But the gyroscopic force required to counteract a ship's roll is immense. Italian designers fitted their ship with 3 huge gyroscopes. As waves rolled the ship one way, motors tilted the gyroscopes. The force of the gyroscopes pushed the ship in the opposite direction. This counteracted the rolling motion of the waves, keeping the ship upright. Thanks to her gyroscopes, the Conte di Savoia was known as the rollless liner. She was a huge hit with passengers who could fully appreciate the fine food on board without getting seasick. Unlike the Conte di Savoia, the Independence of the Seas doesn't use cumbersome gyroscopes to keep her stable. Instead, she borrows a trick from aircraft technology. The Independence of the Seas glides through the ocean as steady as a rock. To keep her stable, even in a heavy swell, designers have fitted her with small fins that jut out from either side of the ship's hull. Each one is streamlined so that it slices through the water without producing much drag. But when it is set at an angle, it acts like the flap on an aeroplane's wing, and either pulls the hull deeper or pushes it higher in the water. As waves try to roll the ship one way, the fins push the hull in the opposite direction. This way they keep the ship vertical, even in a big swell. Having such a stable ship means, just like the Conte di Savoia before her, most passengers can enjoy their food without getting seasick. It also makes life a lot easier for the 480 onboard waiters.
Especially in the older days with the smaller ships, at one minute you find yourself walking uphill, the next minute you're running down the hill. So it was a bit difficult. You had to have good shoes, good grips and strong legs.
Good evening, everybody.
There is no vibration, there's no rocking, there is nothing. It's a city at sea. You don't even realize that it is moving at all.
Back in 1931, the Conte di Savoia proved that a stable ride sold tickets. But to break into the new luxury market, the designers of the SS Normandie would have to make their new liner the last word in opulence. In the early 20th century, around half the passengers on board the great liners traveled third class. They were immigrants on their way to America in search of a better life. But in 1924, when America closed its doors to new arrivals, this market dried up overnight. To survive, liners had to attract a different kind of passenger.
They had to find a new source of income. So where did you look? You looked for the luxury trade. And for a luxury trade, you needed a luxury liner.
In 1931, French designers decided to build the most luxurious liner the world had ever seen, the SS Normandie.
The French designers didn't want to just create any old ship. They wanted a vessel that would be a showpiece for the talents of the whole French nation. They wanted grandeur. They wanted space. They wanted something that would be the match of the great Palace of Versailles. The great saloon for first-class diners would seat 700 diners at one sitting. And when that was finished, it could be cleared away and it could be turned into a ballroom to enjoy the delights of an evening dance.
But clearing the decks for such a large open room proved a real challenge for the ship's designers. In traditional ships, the heavy engines sat low in the hull to provide stability. The engines produced a lot of smoke, which designers normally channeled straight up through the decks and out of large funnels. But this left no space for a great ballroom in the center of the ship. Designers could have raised the engines to the upper decks, but this would have made the ship top-heavy. Shifting the engines and funnels to one end would also have made more room. But this wasn't a good idea either. Shipbuilders had to leave the engines where they were and find a new way to get rid of the smoke. Their solution was simple but elegant. To make space for the great ballroom, French designers split the boiler vents in two. The smoke now traveled up chimneys either side of the central room. The two halves rejoined above and fed into the funnels. The engines were still churning below, while the passengers relaxed in luxury above, blissfully unaware of the hot smoke passing through the walls nearby. Not only was the SS Normandie the fastest ship across the Atlantic, but when she first sailed in 1935, her great ballroom was the largest room on any ship ever built. First-class cabins cost up to £13,000 in today's money, but it was a price over 800 passengers per voyage chose to pay. This was a profitable new market for the luxury liner. Just like on the Normandie, the designers working on the Independence of the Seas wanted their ship to have the biggest room of any cruise ship ever built. A huge atrium, 136 meters long and 5 decks high, in the center of the ship. They call it the Royal Promenade. But times have changed since the Normandie set sail. This isn't a ballroom, it's a giant shopping mall. To stop the promenade from buckling in a heavy sea, engineers strengthen it with steel supports.
Inside these marmor-covered pillars here are steel structures that goes all the way from deck number 3 and they go all the way up to deck number 8 here. And they prevent everything from falling apart or from collapsing. It maintains the structure this way and it also maintains the structure that way.
But there's one final problem with the ship's layout that designers must solve. Passengers want swimming pools that are open to the Caribbean sun. The Independence of the Seas boasts 3 of them, containing over 500 tons of water. Loading this much weight on the upper decks of the ship should make her top heavy. But the designers have positioned the ship's heavy machinery in the bottom of the hull to counteract the weight of water above.
You want to have all the weight in the bottom of the ship, and that's why we have all the machinery down there, our fuel tanks, our freshwater tanks, and we also have additional ballast water tanks. That is to prevent the ship from going over.
Thanks to her innovative layout, the Independence of the Seas can have vast interior spaces and swimming pools 14 stories high. This means just like those traveling on the SS Normandie 70 years ago, today's passengers can enjoy the journey just as much as the destination. Back in 1935, the French SS Normandie set a new benchmark for stylish travel. She was also the fastest ship afloat. But soon, a rival steamed up alongside. The British liner, the Queen Mary, would attempt to beat the Normandie across the Atlantic and claim her title. Marooned at a permanent berth in California stands a ship that was once the pride of the British merchant fleet, the Queen Mary. Today, she's still open for business as a hotel, but the ride's not what it used to be. The Queen Mary first sailed in 1936, just a year after her arch-rival, the SS Normandie's maiden voyage. Her designers couldn't top the French ship for luxury, so they decided to try and beat her for speed. To do that, they would have to outwit the waves. As a traditional ship travels through the sea, waves form at the bow and at the stern. These waves create drag on the hull and slow the ship down. But while testing scale models of the Queen Mary, engineers realized that waves interacted in unique ways, and this could help their ship go faster. When the crest of one wave meets the trough of another, the waves cancel each other out. Designers used this idea to reduce the drag on the Queen Mary's hull and increase her speed. They fixed the length of the hull precisely so that when the bow wave reached the rear of the ship, its crest coincided with the trough of the stern wave and cancelled it out. This reduced drag on the rear of the ship, massively increasing the Queen Mary's speed. The Queen Mary set sail from her home port in Britain in August 1936, bound for New York. She crossed the Atlantic in just 96 hours, shaving 3 hours off the Normandie's record. She remained the fastest ship afloat for the next 14 years. Just like the Queen Mary, designers building the Independence of the Seas used clever hull design to give her maximum speed. The device they used is visible as a shimmering blue shape just beneath the waterline. It's called a bulbous bow.
The bulbous bow is a structure that is in front of the bow of the ship to minimize the drag and the resistance of the ship going through the water.
Surprisingly, this blunt lump of metal reduces the ship's drag rather than adding to it. Without the bulbous bow, the Independence of the Seas would create a huge bow wave as it plows through the water. But with the bulbous bow jutting out in front of the ship, water is forced up and over the obstruction. This creates a new wave just in front of the bow wave. Just like the trick used on the Queen Mary, the crest from one wave meets a trough from the other and cancels it out. This reduces drag and speeds up the ship. Thanks to this tiny bulbous bow, the Independence of the Seas powers through the ocean at 22 knots, despite her huge bulk. In 1936, the Queen Mary's clever hull design enabled her to travel faster than any other liner. But to build the world's biggest cruise ship, the Independence of the Seas, designers had to solve one final problem. If disaster strikes, they must find a way to keep passengers safe. Today, the Independence of the Seas approaches the last port of call on her cruise. But before he welcomes his next set of passengers, Captain Strajicic has one final task for the ship's crew.
Where is that located?
When at sea, he's solely responsible for the lives of nearly 6,000 people on board. So safety is his #1 priority.
That is the most important thing. I go to sleep with that, I wake up with that, I dream about responsibility and safety of the ship.
So every week, he orders a practice evacuation.
Join your life jackets. Once again, all crew, procedure.
Bravo, bravo, bravo.
1512.
Your attention, please.
1502.
All crew must gather at muster points, then abandon ship.
804. Mobile number 5 ready.
Without the right equipment, abandoning ship can be deadly. In 1968, the Wahine passenger ship was sailing off the coast of New Zealand when she was caught in a storm. She hit a reef and began to sink, with over 700 souls on board. The captain ordered passengers to abandon ship, but the Wahine's fragile lifeboats were open-topped and completely ill-equipped to cope with the furious Pacific Ocean. They quickly flooded with water. "50 passengers were drowned. The lifeboats on the Independence of the Seas are very different. Their strong curved roofs ensure big waves simply break over them. Each boat takes 150 passengers and is equipped with an emergency radio and powerful engines.
We're good to go.
In this drill, the crew have just minutes to launch their lifeboats and motor 800 meters away from the ship. If the Independence of the Seas does sink, she could pull any lifeboats nearby down with her into the deep. So a quick escape is vital.
1 minute, 5 seconds.
Yeah, I see that. So we're waiting.
1 minute 40. Chief Junior responding.
Acknowledge.
Two minutes.
Bravo, bravo.
The drill is a success. Captain Strajicic embarks a fresh complement of passengers and sets sail on a new voyage. Standing on the shoulders of historic maritime giants, the Independence of the Seas truly is the ultimate cruise ship. Until someone builds an even bigger one.